So we're gonna continue with 10.2, more about conveyance, page 230, 231. Sorry. So we're talking about the diodes. So we say the diodes is what? For the direction of the circuit. So in one direction, the resistance is very low. You can see here we have a battery 3 volt and the diode, and then we have the lamp, and it's working. There is a current. Okay. So the reverse base for the diode now here. So for example, this circuit is like this one, but this time you see the diode is here, right? This will turn off. But this time we'll put the diode in the other direction. Now what will happen, this lamp, it won't work. Why? We said the diode have what? Much more resistance on the other direction. It's will have very high resistance. But this direction, it have very low. So let the lamp work, or let the current pass, and it works. You can see that page 230. You see the two circuits. Now, you see down below the rectification, or we want to rectify this circuit. So here we have an input. If we put the oscilloscope, we see this input is an AC. Okay, AC, analog current. That means what? It's up and down, up and down. As we saw there, 1, 0, minus 1. So here we have power supply 6 volt AC. It's coming through diode, and then we have here output resistor. Output resistor is for finding out the output, so we find out. So the output, it will be what? Just half wave, and this will be deleted. So the output is in red, just half wave. So the thing is, this is the AC, and the DC is like this, just normal straight. So now with the rectifier, the diode will go up and down, up and down. There's space for the negative wave, up and down. Okay. Now we can use capacitors to make it so. So when the current goes down, the capacitor charged up. Okay. So it will be, if we have another, this is just for rectifier, but later we'll take two, and it will be like this. Then we put capacitors, and it will be like going up and more capacitor resistance until it will be more near to the straight, like the DC. Okay? So we use it for rectifier. The rectifier, the diode is 1N401, is the most used diode, and we have 1 kilo ohm here for the output resistor and the load. So it's enter AC, and it's out, the output is almost DC. Go back to the potential divider. Now we have here 6 volt power supply or battery or cell. So we have here two resistors, 10 kilo ohm, 10 kilo ohm. They're connected for what? On series. So if you remember, we said in series the voltage will be what? Will be different. They will share the voltage or the potential difference from the cell or from the battery. But here what's happening is 10 kilo ohm and 10 kilo ohm. So that means if we put ammeter here, it will give us 3 volt. So when I need to divide the volt, so I can use these two types of resistor. So series, the current is stable, this is the same in the whole circuit, and the voltage will be different. Now there's another way. If I put a variable resistor, that means this 10 kilo ohm can go from 0 to 10 kilo ohm. So that means what? That means all, when the volt is here, when this is 0, the volt all will be 6 for this resistor. More resistor, less volt here, and more volt here. Again, why? Because they shared from the cell. Okay? So we have a changeable voltage from 0 to 3 volt, depending on the value of the resistor I put. So variable is again, you can change it from 0 until 10 kilo ohm. We talked about also about the LDR. The LDR, we say it's the light resistor or light dependent resistor. We say it's when it's dark. For this LDR, we use it for the garden lights or the park lights or the street lights. So you don't need so you don't need to turn off all the lights that in the street or in the park and turn them on again. Like do that twice each day. So turning, they do this circuit, and the LDR, when it's really dark, the resistance will be so low and they'll let the current pass through and it's open. But when there is light, the resistance is so high and make the light turned off. Okay? Also we have the thermistor. It's also what? It's for the heat. So you can see here, thermistor is temperature dependent resistor, so it's changeable to the heat. And last thing on this 10.2 or 10.02, the reed switch. So you can see in your book, page 131, the reed switch. It have glass case and 2 metal reeds, and they have contact between them. So if we bring a magnet near to it, the magnetic field, this reed switch will fill the magnetic field. So as long you bring the magnet near to it, the 2 metal contact will touch each other, okay, the reed contact, and they will give us the current. There is no magnetic field, they won't give us a current. Okay, so it's just a switch by the magnet.